Yes, then density. Density is very obvious. What is it? Density, this is, yes, mass per volume, which is mass per volume. So as I told before, that for FRP, we just repeated FRP is 1.9 and steel is 7.8 tons per meter cubic, cubic meter, tons per meter cubic. That's it. So that's the idea. And one more time, as we remember that we can use less than or FRP to steel, we can reach the ratio in weight like 1 to 9, which is very cool for us. Then, okay, chemical resistance one more time. So why it's so important for us? Why it is so important for us? Let's talk a bit more deeply here. This is your slab. Even if there's a ground slab, and here is soil and stones wherever, as engineers we understand that your structure, which pulls here with all of the weight of your house building, it causes small deflection always. So we can tell that this structure is always under some tensile, some tension, some force. So it's under the load always. So now you see everything's pretty stable around, but as engineers will understand it always. I mean, here we think that nothing goes actually around, but we know that our planet just rushes with a huge speed around the galaxy center. The same thing, if we think that nothing happens right now, but actually gravity pulls with all this force here. So even after 20 years, the gravity force is going to be the same. Once people bring more stuff inside, we're just going to increase it. So in this regard, every structural engineer just make the calculations to predict lifespan. I don't want to go too deep inside because there is something related to age of material, because during the age material become more weak because of different chemical things happen inside and all the things. I don't want to go too deep inside to this one, but the idea is that if we, let's say, zoom here, and this is our bars inside the beam. This is our bars inside the beam. We know that according to rules, you have to calculate the beam to prevent any cracks opening anywhere. This is the rule. But in reality, cracks can appear. And this is because of, I don't know, some floods, maybe some earthquakes, whatever. During the time, maybe here was a flood, so it removes kind of a part of soil here, but load is still the same, so deflection here a bit more, so it causes a crack. And we know that if crack appears here, it will cause the rusting of all the bar along here within some time. Unfortunately, even if here is 100 meters, rust is going to be everywhere here. And every engineer knows that even if this is a super slab, super concrete, or wherever, tiny cracks are there. This is just life, okay? So we can't prevent water go through concrete. Yes, we can use the hydro insulation, all the things, but cracks are there, unfortunately. So in this case, water will remove every year 0.3 millimeter of your bar every year. So we can tell that after 10 years, you're gonna lose 3 millimeters. So let's say if you have Y12 in 2018, in 2028, you're gonna have Y99, yes, Y9. Whoa. Y9. And the problem is that ultimate stress becomes less. But guys, forces are still the same. Gravity is still here, and we don't want that this structure destroyed after only 10 years, because you know construction is pretty expensive just to think about 10 years. Always we calculate for 25 years, sometimes more. So that's why engineers, they know that minimum ultimate stress they have to handle, let's say they have to handle, all of these bars should be, let's say, Y8. It's enough to hold the stress. Then let's go here. They know this is, let's say, Y8. They add to this factor of safety. They plus to this degradation. Let's call it degradation. And in the end, according to special requirements, then they get Y12. That's it. That's the idea, how to do this. More or less, the idea is like this. Of course, there are much more factors there and everything. I just want to go too deeply, but the idea is like this. So, in this regard, in our case, what can we tell? That if we put, let's say, our FRP-8, after 10 years is going to be FRP-8, and after 20 years is going to be still FRP-8. So there is almost no degradation, but why almost no? Because of course some degradation still going to be there, because life is life and material is material anyway. Yes, this material is pretty, let's say, chemical resistant. It's very true, but even this material can degrade. But we can tell that for after 80 years, so if a lifespan is 80 years, maximum degradation gonna be less than equal to 25% only. This is maximum. Okay? Let's compare with the steel. We had Y12. In 10 years, it's become Y9. Oh, sorry. Y9. So it's 3 millimeters, which is, guys, here, which is 20%, more than 20%, 25% for 10 years. So our degradation, 25% for 80 years. Here degradation 25% for 10 years. This is durability. That's the difference. That's it. So that is why when we talking about chemical resistance, this is the issue we have to take into the account. So once someone build a house and let's say this is something special structure, we have to tell them, yes guys, our lifespan is much more bigger than comparing to steel. And of course, if you have to rebuild your foundation after 10 years, after 25 years, it's going to cost you something. Plus to this, you know this problem, so you will use bigger diameter of steel compared actually what you really need because of this issue.